In this video, I again look at information coding. For lossless data compression. This one is of interest because again it tries to maintain that other invariant which is necessary, and it can be done also. It is also possible. Our objective is to map a number n which is less than m equal to 2 power L dash to a value v which is less than s is equal to 2 power L, where L dash is much larger than L. Okay. Now in this approach we try to define a function. If I denote the ith bit of the L dash values of m, L dash bits L dash bits of m, so not L dash values but L dash bits of m. Okay, then we try and define a function f of I such that summation over 0 less than equal to I less than or equal to L dash minus 1 r power f of I equal to 2 power L. Okay, this is the function we have to define. Okay, now we know that if the weights must add up like that, then the next weight, I plus 1th weight, that is the next leading weight, must be twice the value of the previous one, right? So for we require r power f of I is equal to 2 times r power f of I minus 1, and by the same token we require this to be equal to 2 into 2 times r power f of I minus 2 is equal to 2 square times r power f of I minus 2, and so on like this is equal to 2 cube times r power f of I minus 3, and so on. So in general this is equal to 2 power r times 2 power I times r power f of 0. Okay, we haven't defined f of 0 as yet. Okay, we haven't defined f of 0 as yet. In general we have r power f of I should be equal to 2 power I times r power f of 0. Now taking summation on both sides, we have 2 power 0 less than equal to I less than equal to L dash minus 1 r power f of I is equal to r power f of 0, I'll just take it out, r being a constant and f of 0 also being a constant, 0 less than equal to I less than or equal to L dash minus 1 2 power I. Okay, now this part, this we know we require it be equal to 2 power L, must be equal to r power f of 0 times 2 power L dash. That is r, that gives you r is equal to 1 by 2 power L dash minus L whole power 1 by f of 0. Right, so this is what r comes out to, depending on definition for f of 0. Also we have r power f of I equal to 2 power I times r power f of 0, right? Therefore r power f of I minus f of 0 equal to 2 power I, which gives you r is equal to 2 power I by f of I minus f of 0, right? Since r must be constant, okay, r equal to 2 power I by f of I minus f of 0. Okay, okay, since r must be constant, okay, we require I plus 1 by f of I plus 1 minus f of 0 must be equal to I by f of I minus f of 0. This upon solving, which gives f of I plus 1 f of I plus f of I minus f of 0 whole divided by I. Now by backward substitution, this means in general we have we have f of I plus 1 equal to f of I plus f of I minus f of 0 by I. By backward substitution we obtain, by back substitution we get f of 2 is equal to 2 times f of 1 minus f of 0. You can do this, it will be slightly elaborate, and f of 3 it will be equal to 3 times f of 1 minus f of 0. F of 4 will be equal to 4 times f of minus 2 times f of 0. Okay, f of 4 will be equal to 4 times f of 1 minus 3 times f of 0. Okay, this is 3 times f of 1 minus 2 times f of 0. Okay, so we can clearly see a pattern emerging here, and we have in general f of I plus 2 is equal to I plus 2 times f of 1 minus I plus 1 times f of 0. So this is the general value for f of I plus 2. Okay. So we have, if that is the value for f of I plus 2, we have r power f of I plus 2 will be, upon again some solving and deriving it, you will get this to be equal to 2 power L dash minus L in the exponent itself I plus 1 minus I plus 2 times f of 1 by f of 0. Okay, this will what r power f of 5 plus 2 turns out to be. So f of 0 and f of 1 must be so defined that r power f of I plus 2 is always monotonic increasing. with f of I plus 2 greater than f of I plus 1, which means I plus 1 minus I plus 2 times f of 1 by f of 0 greater than I plus 1 times, greater than I times, greater than I minus I plus 1 times f of 1 by f of 0, which upon solving it, it will give you f of 0 greater than f of 1. So if these conditions are satisfied, f of 0 defined f of 0 greater than f of 1, and r is defined as above 1 by 2 power L dash minus L whole power 1 by f of 0, and the r power f of I plus 2 is calculated like this, L dash minus L time. The sum will add up to 2 power L. Okay, r will be a fractional value, decimal value. So you can define f of 0 depending on how you define f of 0 and f of 1. The sum will add up to 2 power L, and it will still maintain the invariant that the quantity is added for the next value is twice the quantity that is added for the previous value. This is a general which maintains the invariant. It can be part of the general approach or for solving it.